Okay, good morning, guys. So this will be a series of videos for nuclear reactions or nuclear chemistry or nuclear energy. Nuclear energy. Of course, I gave you a reading material for this. That reading material is just actually, that is still the book, Brown. We will just concentrate on that in terms of um, LOs, LOs and concepts. Basically, everything which is written there, because I gave it to you as a reading material. Of course, we have to understand the terms, and we really have to read. Or maybe you should read the whole thing, because that's the one of the uh, excerpt or book I gave you. But in terms of LO, I think I'll just be concentrating on three topics. Actually it's four, but I compressed it into three because that's how I see things. I think I should group it as those three, and those three are that the first one is radioactivity and nuclear reactions. The next one is radioactive decay rates. Talking about half-life, radiocarbon dating, the kinetics of that. Um, and then you have nuclear stability and energetics. So of course, it's already talking about the energy, or probably an introductory on the energy we can derive from nuclear reactions. Of course, that is energetics of nuclear reactions. But of course, you have to understand the stability of this of the nuclides, of nuclear reactions, of those involved in nuclear reactions. Um, okay. So, in radioactivity of nuclear reactions, I think there are four important four decay or subatomic particles that is concerned. Of course, there are a lot of things to read about, just like the antimatter matter thing. But in excerpt or in continuation with our discussion of um, the what do you call this, the subatomic particles, there are other subatomic particles which are actually being discussed here, which is now involved when nuclear reaction happens. So I think the most important, or first, I have to look at these four. I think there are four. The alpha decay. The alpha decay is talking about um, helium atoms. And then you have beta decay. Beta decay is talking about electrons. Then you have electron capture. So these two are actually these three, alpha decay, beta decay, and positron emission, are somewhat on the product side. You can see that they are on the product side, while electron capture is on the um, in the reactant side. So now your chemical reaction will usually have a balance only, not on the coefficient, but usually on the number of protons and neutrons, because we will be talking of nuclide. So basically, if substances change into other substances, or element changes into other element, the proton will be changed, and also the neutron, because I mean the nuc the 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 nucleus will also change. So basically, the nucleus talks about the proton and the neutron. So if the proton is changed, and there are also times that the neutron will change. So basically, the mass, which is the mass number, which is actually the proton and the neutron, will change. So those are the things there. And then you have your radioactive decay rates. It talks about the kinetics. So basically, um, for I think there's only one discussed here, for nuclear chemistry, that is a first order kinetics. Actually, this came from your kinetics. This is actually a differential equation, calculus. Okay. But anyway, it's already solved, so we will be using the algebraic equation for this. But if you will read, so mind you that it is a differential equation, meaning you have to understand your derivatives, or probably, yes, the derivatives. Since you have already done your differential calculus, I think you can understand that. So it was derived. So you have already a algebraic equation. So maybe we can try. And then for nuclear stability, we can. There are also some discussions there, but maybe I can try opening. So nuclide. So based on my notes here. So as you can see, so we will be referring to this as a nuclide. Nuclide. Basically, the Z here, the X is the variable for any nuclide. The A is the number, the mass number, talks about the proton plus the neutron, and your Z is the atomic number. Usually for other books, the Z is not included, but here it is. Why? Because your Z and X is somewhat, repeated. Because the number of the atomic number will tell you in the periodic table what element it is. So basically, just like nitrogen, nitrogen is an atomic number of 7. Basically, the number of protons will tell you about nitrogen. If this is 7, this is basically an another element or an element in the periodic table. So so just bear in mind that your in some books, I might be using other books. So again, the 7 and n is redundant. So you might, some books just extract this 7 for a nuclide. So it just talks about nitrogen 14, so carbon 13, okay? And anyway, you can read it uh, blatantly written. If we say nitrogen, that's like this, nitrogen 14. The mass number is 14, and we know nitrogen has a atomic number of 7. So just bear in mind. So that is a nuclide. So we have already introduced it in chapter 1, I think, on naming isotopes. So now we're back. That is nuclide, and then so the discovery actually comes from Rutherford experiments. It's the first um, discovery of these particles or nuclear chemistry actually from Rutherford experiment. Rutherford is the one who's in charge of discovering the alpha, the beta, and the gamma particles. So actually, gamma, these are, uh, anyway, you can look at it from, I think this is also in connection with how the protons was discovered. Um, there is an experiment wherein some rays pass through while others are being blocked. Of course, though they are being blocked by the protons themselves because they interact. But anyway, in continuation with that, Rutherford um, found out that some rays still, um, because of its interaction with, this one is in magnet, this one is in terms of an aluminum foil. So he saw from an aluminum foil, actually the first one that he discovered is the alpha and the beta particles, because from those two particles, alpha particles doesn't pass the aluminum foil while the beta particles did. So how did he do it? Because he can see in a dark room that um, some rays, because these are rays just like laser, they are concentrated in a, just like the how the atoms how they was discovered. You have usually a metal which is being panipis masyado so that it would be just how many atoms thick, just a few atoms thick, so manipis masyado, and then rays is being passed through it. So he found out that alpha rays, so because the alpha and the beta was first discovered, so the beta, those rays that pass, he called it beta, and those rays that didn't pass, he calls alpha. So basically, in four, just para malaksi, alpha particles are actually helium atoms. So as you can see, it is already heavy. Helium atoms has four mass number, meaning it has two protons and two neutrons. while beta particles are believed to be electrons. So it could just pass. And then why he concluded, anyway, he put it in a charge plates. This is magnets. So he can see that those rays can be bent. I think this is the part here where gamma rays was seen, because those that react with the positive goes with the positive. Actually, it changes direction because you have a positive plate here. So actually, this can be manipulated. You can change, if this is an electromagnet, which is usually an electromagnet, meaning magnet nga gibutangan ning na magnet siya kay tungod it kurente. We have of course a an iron magnet, ferritic magnet nga ito nga magnet is may dagod diya magnet as long that material is there. But electromagnets can be induced, meaning pwede gamitan ng kurente, pakusganin mong kurente, mas makurkusog iti ang magnet. Yan, nakita na kami ito ang mga kutsi kinahang because of electromagnets, or a levitating train na nalutaw nga train because of electromagnets. Sa amin iti concept. So kung positive ya, ang positive nga part, the positive pole will attract the negative particles. That's why beta particles is concluded to be a negative, and later concluded it would be a beta particle are actually electrons because it really interacts with your positive charge plate. Your alpha particle is somewhat has a positive value pero di rin masyado nakaliko because again, it consists of a proton and a neutron. Your neutron has no charge, but your proton has. So it will react with your negative plate. So amit yan lumiko hiya. Actually, inirang nga mga setup amin yung kagamit pag analyze it mga compounds basta kin-ionize hira nga form. Because ini nga imo pagliko actually is dependent on the charge nga imo gimbubutang dinit plate. So ibig sabihin, dependent ka kusog charge, dependent pagliko nga nito nga pagliko ipatama nimo something nga ma-detect ito iya, masasabtan kung ano ito nga mga elements. So amo ito actually king kagamit iton mga pag-analyze iton mga elements or compounds because your compounds has elements to it. Okay? Ang mga makabag-o nga technology that analyzes elements in water, in gas phase, or in solid, nga gipapagas, so suga din it iya concept. Okay? So anyway, you can read that one. Okay, and then you have your alpha decay. So alpha decay was first studied with uranium. So you have your alpha decay with uranium. So this is your alpha decay. This is your alpha particle, your helium-4. When a nucleus undergoes an alpha decay, it ejects an alpha particle. So this is your alpha particle so that its mass number decreases by 4. So this chemical reaction or nuclear reaction decreases the mass number by 4 because it is now, the 4 now is on the helium atom. Okay? And decreases the atomic number by 2 because your helium has an atomic number. It's a proton number of 2. So basically, your uranium-238 becomes a thorium-234. Okay? So that is an alpha decay. It's a nuclear reaction wherein an alpha particle is being ejected or in the product form. Meaning after the chemical reaction, you have a uranium-234 and a helium atom which is being ejected as maybe a radioactive decay or as a radioactive material. Sa amo na ini din ni mga radioactivity. So okay, you can actually read the the life of those which studied radioactive decays nga diri pera maaram. I think the Curies, mga Curies mag-asawa pera nga nagkaka-cancer because of course diri para maaram nga ining mga decay is changes the I mean pag natama aton lawas na change it aton na mutate it aton mga genes. So actually they died in cancer. How sad. though nakakarawat rin mga Nobel Prize. Pero kasi hirapan pinakauna nga nag-study ni. And you can read, I don't know with Rutherford, maybe. So, nangalimutan ko ang Rutherford story. But anyway, sa amo nagapiniti pakadto nga pinagdadala ng mga mga bombs nga tika nga nuclear reactions. Okay? So you have alpha decay, and then another one is you have your beta decay. So beta decay is like this. So you have this one is the beta decay. So again, alpha, wala na igbutang alpha. But actually, an una, of course, that's just represented as alpha. And then they found out that it's a helium atom. So gini-helium na leya para there na wala na ambiguity. So a beta decay, you have your beta. Again, for a beta decay, actually ini nga duduha permanente ni gibubutang. There's also an ejection of a proton because it bodies talaga ti mo electron is proton. So meaning pag sumira ni beta decay, aada gihap ini nga duduha. You have just like this. May niya permanente tulo. Bisan nila because may kita na yung ini ito sa nga product just like a beta decay of carbon-14. Carbon-14 is being used pag measure an imo radiocarbon dating, which is for half-life liwat nga topic. So, your carbon dating disintegrates or undergoes a beta decay. So, amin actually gin may measure. Pag decay niya, gin may measure half-life. So, nasasabtanan kahirayuhan life, han imo organic material. So, kikita ito nimo carbon-14 nga nag-react nga naging nitrogen sa may mechanism ito, may computation kita to dida nga nasasabtan ano ka dugay because that's a fixed thing an imo half-life. But anyway, carbon-14 undergoing beta decay, so nagiging nitrogen-14 niya with a beta decay, and you have your antineutrino. Duduay ni may da viliwat nga sa neutrino. So, antineutrino, pag mag-beta decay, permanente ibutanghi anti-neutrino. So, nakikita niyo nga, waray hiya charge, ngan waray hiya mass. You could just imagine an electron nga waray mass. Actually, may mass ganito nila, pero of course, por pareho lat electron. Waray mass, pero kay waray man niya proton, ngan waray niya neutron. So, basically, pagayahin diha mga electron niya kabugat. Actually, so we call that an antineutrino. The V with a may dahigpaw. So pag sumiringan niya again beta decay, ibubutang mo yung antineutrino. Of course, your beta and of course the product of your decay. So just like carbon-14, it will be nitrogen-14. So you can do this actually because if you have a beta which is usually like this, may waray niya proton neutron, so zero yan didikpaw. Your antineutrino waray niya proton neutron. So basically, this 14 would be 14 here. So depende nila kung ano't masasalin niya. For your beta, that would have a negative 1 because electrons, this is the charge. The electrons will mag-iibat ira charge. So your 6 minus 1, your 7 minus 1 is actually your 6. So durda ko din ito nimo charge 7 kay adi diditim negative charge. Okay? So may nakita ito mga problem ito and we will just solve. The next is electron capture. So for your electron capture, you have the medyo amin iton diha pag sumaringani K-capture or electron capture para ilotera K-capture, electron capture. Your electron is on the reactant side. So pag sumaringani electron capture, may da ini permanente and of course ini nga dudot constant. You have your electron on the reactant side and your neutrino, your V. So adit mo product of nuclear reaction. So, example din you have your aluminum 26, the product is a magnesium 26. By capturing electrons and the neutrino is being ejected. Okay? So, anyway. And then last one is your positron. Your positron emission. Pag sumering positron emission, may Decay ni. Positron is believed to be the antimatter of your matter because the first one discovered as matter or subatomic particle is electron. So, your antimatter is actually for electron is positron. That is an electron with a positive charge. So, see? So, positron, actually, I think they do believe, just like this example, a proton actually is consists of a neutron and a positron. So, nakita na ninyo, ang suludan imo nucleus nga proton. So, they believe that proton is actually a product of three. So, kung i-represent natin aton kada usa nga proton, di pa sa atomic particle man natin pagkaintindi. So, now, your proton now is actually a neutron itself. A neutron without charge but with a one mass of 1, and a positron without charge, without mass, but with a charge, 1. And then you have your neutrino, which is no charge, no mass. Or maybe the mass is somewhat on the 1,000 times than your proton and neutron. So that's how we visualize these things. Okay? So those are the 4 important nuclear reactions. So again, pag sumiring alpha decay, may danimo helium atoms. And then pag sumiring beta decay, may daka electrons nga gini-eject. Pag sumiring electron capture, may danimo electrons nga gin ka-capture dito ada ato akuan. So what is the difference between beta decay and electron capture? Nakikita ka na ngalimot ako. Your beta decay is 0, -1. Your electron capture is 0, -1. So actually, your beta is the same as electron. Kaya lang, ang electron capture, ibubutang iraha reactant. I don't know pa. I think ang ibang libro, beta lagi hapon niya. Ay, beta. Oo mo na. Beta lagi hapon. Because pareho tira notation. At 0, -1. So, hindi nga book, bear in mind nga, ang aton 0, -1 is talk about electron kung ada yaha reactant, but it is called beta kung adto yaha product. Insigurado ko lang kay bangin kasi manos. That is 0, -1. Okay? So, may mga example, magsasolve na lang ako. Then, for decay rates, actually, tat importante lat dida, iton imo half-life. So, your kinetics actually is just, rin na ipakita differential equation. So, diretso na, solve algebraically, and for nuclear, just like radiocarbon dating, you already have your half-life. So, your half-life is amo ito an imo time kundi in katunga nan concentration ng imo particular nuclide ang nabilin. Okay? So, we call that half-life. Just like radiocarbon dating, may mga half-life. Ito ni mo radiocarbon 14. So, nasasabtan. Kung katunga na ito naiban, so basically, amo na ito nga years ang naglabay para ang concentration is amot kadamo. Again, ang kadamo, nag-iiba, pero ang concentration nimo is, meaning, kung dako nga bato, damo. Pero concentration nimo, whether dako nga bato, guti nga bato, dako nga organic material, guti nga material, parehot concentration it imo nuclide. Sa amo ito importante ito imo half-life or naton concentration niya concept. Di ba? Kumuha kahin acid gintunaw ni mga tubig nga nag-divide na equally, kumuha kan portion nito imo concentration papreho. Okay? Do ang kadamuhan imo asin na depende kung ano kadamuhan volume. Pero nimo concentration, it doesn't depend on that. So, as long nakakuha ka line portion, tas na-analyze nimo because just like animo asin niya gintunaw nga tubig, papreho ito bisan diin, which is concentration, proportionate at half-life. Animo concentration, basta nakakuha ka lang kutay nga part, animo concentration and imo nuclide dida is the same. So that's why it can be analyzed. So half-life is T1 half, ln 2, this is a constant number, ln 2. Again, you can input the calculator, that's 0.693 over now your K. which is actually your constant. Kung ano man ito yung nagdi-decay. Okay? So meaning it constantly din actually your if K is constant for any chemical reaction, kaya lang variable kung ano nga nuclear reaction ang minisiring, so constant kapit mo half-life. Okay? So it K, depende na kung ano kinistorya, kung carbon 14, kung ano nga nuclide. Well, your half-life, amin it may tabulation, I think. Your half-life has tabulation or we might be computing for half-lives kay para pag-solve iton time. Iton imo nuclear reactions. Okay? Sa amin it imo radioactive decay rates ang galaxy ang kadugay hanimo radioactivity. And next, again these three topics hindi na lang ato no. Then for nuclear stability iragim plot actually ang mga nuclide, and they have found out sorry guys, medyo may kuan ako sipon. Ngan they have found out that there is a region of stability. So, plot nira, divide nira ang imo neutron number n neutron number n or an imo with respect to atomic number z. So, your neutron number of course is your neutron o your neutron number. Kada mo nira neutron. So, divide yung letter blatantly. Neutron with respect to the z. The n over z. And they found out nga may dala pattern hain nga mga nuclide iton imo stable. Amin nga mga blue. So, amo litiya. So, ini nga mga blue are stable nuclide. So, nasabtan nila nga mga stable kay madugay hinduro it iya half-life. Samantalang inihira ito mga half-life is, ini mga orange is hilipot. So, paano mo na nasasabtan? Of course, with research. Iragin mo-monitor ang mga nuclide. So, nasasabtan nila nuclide after a certain time, waray na ito ya, or ni half-life. Kaya ba, of course, ay pinankuha naman ng mga half-life. So, nasabtan nila nga there is a part wherein mga stable hira. And we call it the band of stability. Nuclear shell of the band of stability often undergo positron emission, so may pattern pa niya and above usually nagkakamay din positron emission or electron capture. It ada igbaw talang it ada ubos usually undergo a beta decay nuclei. Actually ito delikado ni nga ini nga mga beta decay, gamma decay, beta decay. Amin iton mga kadto mga bomb. You can see nga amin iton na-mutate kaka-causing cancer actually. Nuclei with an anniversary ratios below the band of stability often undergo a beta decay. Okay, so that's how you interpret this. So, divide lang nila neutron with respect to proton, and you have this plot. Kung hain nila the x and y. Okay? And then, the example of a decay, you have your uranium-238 decay. So, this is an example. You can do this if ever you know the chemistry behind. So, anyway, so this is the chemistry of your uranium-238 to lead-206. So, they found out your uranium-238 will undergo series of nuclear reactions until lead-206. So, naisa pa lead-206 kaya amot may pinakahilaba nga half-life. So, meaning at siya ba stability nga atakuan han blue. So, anyway, summary niya para malaksi pagkita. Your uranium-238 will change atomic number with respect to neutron numbers. May kita nyo, your uranium-238 magiging thorium-234. Pero again, padayon lang tira kay ini, itira mga half-life ini, thorium, iniya, you have your polonium, and you have your lead is mga, may da mga half-life nira. Di. Lead and added diha. But anyway, so just as an example on how we view nuclear reaction from unstable nuclide to a stable nuclide. So, daan naging susugad tiya para malaksi. Pero daan na iliwat sa mga books, hindi diretso tiya, uranium-238, may chemical reaction niya da. Daan ay series at chemical reaction para makaabot ito 06. So, ito nga kuan, I think mas malaksi ini pag-interpret. Kaya nakikita mo uh, iton imo neutron number and atomic number. Okay. So, anyway, just an sample. Magsasolve man lang kita mga problem. Na ako malain is, gamay nga discussion siguro para malak sila. But anyway, you can read your book and then makato na ako solving. But because reading actually is your side. Diba? Ako nagbabasa lalot ako tapos akong discuss is from my reading. So, this one is again going back to accounting the usually binding energy basic niya. So, bagayan theoretical nga makukuha nato ni chemical reaction. So, binding energy, I think this discussion is nag-example na lang din paano nakukuha binding energy. So, this is a computation about helium. So, ani mo helium, may experiment, di ba kang aton periodic table, nakuha na ito, itiya mo mass, tapos ging compute hiya, pinaagihan imo mga masa nimo sa atomic particles. Okay? Nga nakita nila nga may discrepancy. Okay? And that discrepancy, we call it a mass defect. So, that delta M. So, yan nga delta M, amo itong gimbutang dili kay Einstein equation that says that your energy are just masses multiplied by the velocity of light. So, ito yan na nga M, kay di mat ma-account nga tanan nga energy, kaya ada man ito solid. Diba? Kumbaga, itira nga tanan. Nga talking about protons, neutrons, and anything in there, converting it to energy. So, yan, at makukompute lang natin, ang na-bind ha era. Usually, adto ha, nucleus nga side. Kaya ni mo electrons kasi, naglupad-lupad matiya, so they're bounded. Okay? Bounded, lahira, liwatan era, paging positive and negative ha imo neutron. Pero yan, ani mo nucleus nga gugotihan duro, kay tungod nga nag-compress sira masyado dida. So, they are bounded, or binded. So, ito nga bind, gina-account ito nga tanan, hanera mga mass, nga na-compute ani mo mass defect. Ano ang pagkakaiba? Han imo usa nga ada periodic table nga maram kita mass, nga with respect to computation, han pag-compute lan mga neutron, man pa rin eh. Your helium is from masses up to hydrogen atoms, which is 4.03, meaning theoretical ito and from experiments, 4.002603. So, meaning, if you want to derive helium from hydrogen, theoretically, amo ini nga tanan ang iya mass. Pero, we found out nga, dere, kay tungod nga, ang iba niya nga mass is something, itong air difference is amo ito na bind it imo nucleon, it imo nucleus. So, we call it mass defect. Diba? Kaya nami-measure na niya, kaya natitimbang naman. So, we call it mass defect, delta M. We plug it to Einstein equation. For Einstein equation, all you have to plug is just the mass. That mass. So, hindi din nga case, that is the, kaya physics, may dalot inira. But anyway, chemistry, amo lang niya, nuclear. Anyway, this is just basic. So, that delta M is the mass defect, and then the product of this, delta M and C squared, of course, changing it to energy, that would be the binding energy. So that's the binding energy. If you want to compute the binding energy, we only have to have the mass and then constant na imo C, which is a 2.99792 times 10 to the 8. Then you have a conversion of 1.66054 times 10 to the negative kilogram per atomic mass unit. This is conversion of atomic mass with respect to kilogram. Conversion factor between mass and kilogram. So there is 1.66 0.54 times 10 to the negative 7 kilograms per mass unit. Okay? Sorry. Binding energy, mass defect. Makatulong kita mga problems. Okay, and the last one is somewhat stability. Binding energy per nucleon and mass number. So, anyway, magic numbers are ginkita nira ang mga stable nga isotope ngan mga stable nga isotope nga nakita nila pinaka-stable actually is iron 56. That's why iron is believed to be the core of the earth. Iya kasi pinaka-stable. So, tipagawas niya, of course, and di rin na stable. Okay? But anyway, gin-graph nila ang binding energy with respect to mass number of the stable isotopes. And iron 56 is the most stable nucleus. Anyway, you can just read it from the book. So, nagbabasa lalot ako. Okay? So, somewhat, introduce ko lang kung ano nga mga topics an aton pagsisinulbon. Meaning, inilang nga tulo. Adi, Rael Anay. Meaning, ita ko nakakabulon laha LOs is ini nga tulo. Nga namo gapit ako pagsisinulbon ng mga problem solving. Okay, thank you guys for listening. I'll cut.